Alright, so we're going to be doing an AP calculus problem, and what we're going to do is consider the curve defined by the equation y plus cosine y equals x plus 1. Keep in mind that the range goes from 0 to 2 pi. First, we are going to find dy dx, so we need to take the derivative of this equation. It's important to know the derivatives of the trig identities in order to successfully solve this problem. Once you know that, you can take the derivative of the equation and it should be very straightforward and end up looking something like this. Now, we want to solve for dy dx, so we need to try to isolate it. To do so, you would take out the factor of dy dx and your answer should now look like this. To finish this problem and fully solve for dy dx, all you need to do is divide by 1 minus sine y, and your final answer will look like this. Now we need to write an equation for each vertical tangent to the curve. Now remember, a vertical tangent is when the denominator of your derivative equals 0. The denominator of our derivative was 1 minus sine y, so we're just going to go ahead and set that equal to 0. Now we need to move the 1 over to the other side and solve for when sine y equals 1. The only answer would be y equals pi over 2 because that is the only value in our range that makes this equation true. Now, to find x, we need to plug this answer into the y value of our original equation. So we're just going to go ahead and plug pi over 2 in for y. Then try to simplify what we can by solving for cosine of pi over 2. Then solve for x by moving the 1 over to the other side of the equation. The last thing to do for this problem is find the second derivative in terms of y. Therefore, we are going to take the derivative of the derivative. So here's what our derivative looked like from when we solved it earlier. Now we are going to take the second derivative. We need to apply the chain rule, so our answer will end up looking something like this. To make things easier to see, we are just going to make our exponent positive by moving the 1 minus sine y to the denominator. Now we know what dy dx is, so we can substitute that in for the dy dx that needs to be multiplied by the fraction we have, and it should look something like this. Finally, we are going to simplify this by adding our exponents of the denominator, since both denominators are 1 minus sine y, and the final answer will look like this.